And this I'm going to solve this example of limits, and I'm going to start by testing this limit and see what happens once we approach to this value of x equal to 1, or this approaching to 1. So let's evaluate and see. It will be 1/2 minus, notice that I'm not writing here the limit notation, this symbol, because we are evaluating. So it will be, again, will be 1/2 minus, this will be 1 plus 1, 1 over 1 plus 1. This will be all over 1 minus 1. And of course, here would be 1/2 minus 1/2, and below we'll have 1 minus 1. And I think you will notice that we have in this case a 0 over 0. So we have to do something in order to sort this out. And in order to do it with these limits, there is a series of strategies we have to solve. And in this case, it's pretty easy to identify what we have to do, because as long as you have fractions that are involved in the process, then you have to do something about this process, these fractions, which is called getting a common denominator, which is nothing that new, nothing that spectacular from algebra. So I'm sure you will get familiar with it pretty quickly. Now, let's see. I'm going to start by copying out a few things. Okay, let's get to it. Let's get to it. Okay, here it is. So we're going to get this common denominator. So this 1/2, this 1/2, we're going to multiply times the denominator of the other fraction, which is this x plus 1. And so we're going to multiply it this way, x plus 1 over x plus 1. In order to, this is like multiplying times 1, so we're not affecting the fraction of 1/2 technically. And we're going to do the same trick with the other fraction, which would be minus 1 over x plus 1 will be times. In this case, we're going to multiply, in order to get the common denominator, we're going to multiply times the other denominator, which is this 2. So it will be 2 over 2. And then below we have in the denominator this x minus 1, that we can do anything about this x minus 1. So we're just going to keep it this way, just like it is. Now let's see. We're going to let's just continue here, down here. Let's continue. And now these fractions will look slightly different now after this doing this multiplication. Let's see how they will look. In this case, it will be x plus 1 over 2 times x plus 1. Here will be minus 2 over 2 times x plus 1. This will be all over x minus 1. There it is. Now, once we have the fractions in this way, that we have this 2 times x plus 1, the common denominator, we can add the fractions. It's pretty much the same thing. It's pretty much the same thing we're doing in here, this processing. I'm actually going to continue. I'm going to scroll down a bit. This screen, there it is. So let's continue. I'm going to copy here this part of the limit. There it is. Let's see. Now the fractions, now they have this common denominator, they will look this way. It will be 2 times x plus 1. We can now add the fractions in this way. It will be x plus 1 minus 2. Now that they have the same denominator, it will be all over this x minus 1. Now, of course, simplify something from here. This plus 1 minus 2, we can rewrite it. We can rewrite it this way. And then we will get to this expression. Will be x minus 1. This is over 2 times x plus 1. And this would be again over this x minus 1. I think you have a hunch of what's going to happen. This x minus 1 that we have a denominator, this guy, this one, it's implicitly over 1. Now this over 1, we can do here something that you may notice. You may call this a sandwich rule. I don't know why, but this is the way you call it. So we're going to multiply the terms in between times the outer terms, and we'll get to something that I think you'll notice what's going to happen in a moment. We're going to simplify this expression in a very nice way. We'll get to this. And the expression will look like this. It will be 2 times x plus 1 times x minus 1. This is all below x minus 1. Now from here I think it's pretty evident what we're going to do. This guy, the x minus 1, it's on the numerator and the 1 on the denominator, we can cancel them out. We can simplify this expression like this, and we get to something much nicer. Something that will look like this in a moment. And we'll get to this expression, which at the end will be 2 times x plus 1. Below, yeah, we have 1 over 2 times x plus 1. So now this expression, after we simplify these terms, this x minus 1 was the one that was causing implicitly this problem with the 0 over 0 that we had at the very beginning of the problem, which is this piece. Now after simplifying the x minus 1, now we fix that problem in a way to say, after simplifying the terms, we have to always check out and substitute the value for x that we have in here. So let's try it out and see if we get to something that's actually causing no trouble at all. So let's see, substituting the 1 would be 1 over 2. Here we have, I'm going to use a different color just to make this processing clear. This one would be in here, and I think, you know, it's clearly not going to be no trouble with this guy. 2 times 2, and at the end we got the result is 1/4, and that's actually the solution for this limit, 1/4, and that will be it for this one.